dear students, welcome back to mathematics class. Hope you all safe at home. And coming to today's concept is about harmonic conjugate and area of the triangle. So before going to discuss about these concepts, let us solve few more problems related to the concept of centroid of a triangle. Okay. Coming to the first question. If two vertices of a triangle are 4, 8, minus 2, 6 and the centroid is 2, 7, then find the third vertex. So please try to understand the question, that what is given and what is asking. So this time centroid is given to us and two of the vertices of a triangle are also given to us. And finally we need to find the third vertex, right? So coming to the solution, first of all assume that the given two vertices are, one is capital A and one is capital B. Hence let the given vertices be, capital A is 4, 8 and capital B is nothing but minus 2, 6. And let the third vertex be, since we need to find the third vertex, no? So assume that the third vertex be capital C, some x, y. Some x, y. So also provided that centroid, which is denoted actually with capital letter G, which is equals to already given that 2, 7. So we know that formula for centroid is equals to x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3, isn't it? So coming to centroid is already given that 2, 7, which is equals to, so x1 plus x2 plus x3, nothing but x coordinates of vertex A, vertex B and vertex C. So what is it? x1 is 4 plus x2 is minus 2 plus x3 is x. So 4 minus 2 plus x whole divided by 3, comma, similarly y coordinates 8 plus 6 plus y by 3. Now 4 minus 2, which is 2 plus x by 3, 8 plus 6, 14 plus y by 3. So which is equals to actually 2, 7, no? So hence you can equate x coordinates as well as y coordinates. So x coordinate, that is 2 plus x by 3 is equals to 2. Both sides I want to equate x coordinates as well as y coordinates. So on cross multiplication, 2 plus x is equals to 6 and x is equals to 6 minus 2, which is equals to 4. Similarly, if you equate y coordinates, then 14 plus y by 3 is equals to 7. On cross multiplication, 3 into 7, which is 21. Now y is equals to 21 minus 14, which is 7. Hence finally we want the third vertex, that is what is x and what is y. So what we got, x is equals to 4 and y is equals to 7. Hence therefore the third vertex, capital C, is equals to 4, 7. Coming to the next question, the centroid of triangle ABC is 2, 7 and the points capital B, capital C lie on x and y axis respectively, and capital A is equals to 4, 8. then find capital B and capital C. So first of all, once again try to understand what is given and what is asking. So clearly first one, centroid is given as 2, 7. So given that centroid capital G is equals to 2, 7, right? Now coming to the vertices ABC, see this time provided only one vertex, that is capital A. Capital A is nothing but 4, 8. And the remaining two vertices we need to find. That is what is capital B and what is capital C. And for that, there are some conditions are given that capital B is a point which lies on x-axis and capital C is a point which lies on y-axis. Okay, fine. So, since capital B is a point on x-axis, then we discussed already a point on x-axis, that means its y-coordinate must be 0. Something comma 0. The point must be something comma 0, because since it is a point on x-axis, y-coordinate must be 0. X-coordinate you can assume something, a comma 0, p comma 0, k comma 0. If not, let me want to assume some x comma 0. X-coordinate can be anything. Maybe 1, 2, 3 or minus or anything, 0 also. But y-coordinate is strictly 0 on x-axis. So similarly, C is a point on y-axis. That means this time, since C is a point on y-axis, its x-coordinate must be 0. So x-coordinate is strictly 0 comma something, you can assume it. Let it be 0 comma y. So in the entire problem, these are the two important points you need to identify. Since B is a point on x-axis, therefore its y-coordinate is 0. And x-coordinate you can assume anything, general, a comma, b comma or k comma. So myself I want to assume it as x comma 0. And since C is a point on y-axis, here C must be considered as 0 comma something. Okay. As usual, the formula for centroid is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. Okay. So, centroid is already provided, same in the last problem also, that is 2, 7. Now, let us see what are x1, x2, x3. x1 is 4, x2 is x, and x3 is nothing but 0. I mean only x coordinates. So 4 plus x plus 0 whole divided by 3, comma, similarly y coordinates, that is 8 plus 0 plus y whole divided by 3. Now this is nothing but 4 plus x by 3 and this is 8 plus y by 3. So as usual, can equate x coordinates as well as y coordinates. So from this 4 plus x is equals to 6 and once again x is equals to 2. And coming to here 8 plus y is equals to 3 sevens are 21. Then y is equals to 21 minus 18 which is equals to 13. So therefore, since we know x and y now, therefore the vertex B is nothing but actually what we assumed, x comma 0. Now x is nothing but 2 and the vertex B is 2 comma 0 and similarly vertex C is, what is the y value? 13. Hence vertex C is 0 comma 13. So next one, which is very important, that is harmonic conjugate. So first let us see the definition of harmonic conjugate. If a point P divides the line segment joining the points AB, I mean this is the situation. Suppose let it be A and let it be B. Okay. let it be P, and P is somewhere here. So see, if a point P which divides AB bar, the line segment AB bar, in the ratio L is to M. Okay, ma? So if a point P which divides the line segment joining the points AB in the ratio L is to M, then the point Q, this is the point Q, the point Q which divides the AB bar in the ratio L is to minus M. So Q is dividing in the ratio L is to minus M, is called harmonic conjugate of P with respect to capital A and capital B. Do you understand? So listen carefully once again. So as per the definition of harmonic conjugate, so look at that. AB is a line segment and P is a point which lies inside the AB. I mean, the meaning of dividing L is to M nothing but P divides AB bar in the ratio L is to M internally. Suppose if P divides AB bar in the ratio L is to M internally, then Q divides in the same ratio L is to M externally. That's what we mentioned with the negative sign. This negative sign indicates which divides externally. So please listen carefully, ma. If P divides AB bar in such a ratio L is to M internally, then Q is a point which divides the AB bar in the same ratio L is to M externally. Then P and Q are said to be harmonic conjugate to each other. Why? Because sometimes the situation can be like this. Maybe Q is a point here which dividing in the ratio L is to M, and P be a point here which is also dividing in the same ratio L is to M. But see, since Q is inside of AB, we say that Q divides AB bar internally, whereas P is comparatively AB out of AB, hence P divides AB bar externally. So both ratio is same. So that is what, instead of internally and externally, so we are telling that one point dividing in the ratio L is to M, then the other point is dividing in the ratio minus L is to M. L is to minus M is nothing but minus L is to M. Do you understand? So then each point is said to be harmonic conjugate to each other. For example, if P divides AB bar in the ratio 2 is to 3, then if Q is the harmonic conjugate of P, then you know Q divides AB bar in the ratio minus 2 is to 3. Okay, ma'am. So the only thing is one is dividing internally and the other is dividing externally. That internally and externally we are showing with the symbolically. Positive sign indicates internally, the negative sign indicates externally. Okay. If suppose P itself dividing in the ratio minus 2 is to 3, sometimes P can be outside also, isn't it? Then you know Q will be minus of minus 2, which is nothing but plus 2. Hence Q divides AB bar in the ratio 2 is to 3. Right? So please remember that P and Q are the 2 points which are dividing AB bar, a line segment AB bar, in the same ratio L is to M. But the thing is, one point divides internally and the other points dividing externally. Hence each point, I mean P is said to be harmonic conjugate of Q, as well as Q is said to be harmonic conjugate of P. Okay. So let us solve one problem related to this concept, that is, how can we find the harmonic conjugate of a given point. So read the question, everybody. Find the harmonic conjugate of 7, 5 with respect to 4, 2, 9, 7. So first you need to guess here what are given. Actually there are 4 points, no? A, B, P and Q. Out of these 4 points, provided only 3 points here. So first let us try to identify what are the points are given. So if you read the question, then with respect to, hence these 2 points you can read them as one is capital A and one is capital B. So this is the line joining of 2 points. And we need to find out the harmonic conjugate of this point. I mean this can be P or this can be Q. So let me want to assume this is as P. Okay. Now if I want to find Q, I want to know that Q divides AB bar in what ratio? Okay. But this is depending on P divides AB bar in what ratio. So first let us find the ratio that the point P divides AB bar. Okay. So whenever we want to find the ratio that the point divides, then we discussed in the last class that let us assume the point which dividing the line segment in the ratio some k is to 1. Instead of m is to n, better you can proceed with k is to 1. Now see, the points A and B are nothing but x1, y1 and B is nothing but x2, y2. And the ratio k is to 1 you can compare with m is to n. So since I want to know the ratio, let me want to use section formula. mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. So m and n nothing but k and 1, and these are the x1, y1 and these are the x2, y2. So let us substitute the values. M k into x2 which is 9 plus 1 into x1 4 by k plus 1. M plus n is nothing but k plus 1. Similarly y coordinates. Now 7 comma 5 is equals to 9k plus 4 by k plus 1 comma. This is 7k plus 2 by k plus 1. As usual can equate x coordinate or y coordinate, any one is enough because to find k value. So let me want to equate x coordinates on both sides. So because I just want only k value, so only one thing I can equate, that is enough. Then cross multiplication 7k plus 7. So this is 9k minus 7k is equals to 7 minus 4. Hence 2k is equals to 3. And from this k is equals to 3 by 2. So actually we assumed that ratio is as k is to 1. That is I can replace now k with 3 by 2 is to 1. So both sides better you can multiply with 2. No, in equalities we studied that when we multiply both sides with a positive quantity, then there is no change. So let me want to multiply with 2 so that this 2 and this 2 gets cancelled. Now this is 3 is to 2. So therefore what we can conclude that hence P divides AB bar in the ratio that is 3 is to 2. In the ratio 3 is to 2. Therefore because of a harmonic conjugate, Q divides AB bar in the ratio which is minus 3 is to 2, isn't it? L is to M, then other one is minus L is to M. So now I know that Q divides in what ratio. Hence now I can apply once again to get the coordinates of Q. Once again let me want to apply the section formula. So x1, y1 and x2, y2 are same, but this time m and n are changing. So this is the m and this is the n. So now m into x1, that is m x2 minus 3 into 9 plus 2 into x1 which is 4 by minus 3 plus 2 comma, similarly m y2 plus m y1 by m plus n. So since I want to find the coordinates of q, let us simplify. Minus 27 plus 8 by minus 1 comma, minus 21 plus 4 by minus 1. Hence q is equals to, is this minus 19 by minus 1, and coming to this is minus 17 by minus 1. So signs are getting cancelled, hence q is equals to 19 comma 17. So this is the way we can find out the harmonic conjugate of the given point. So see that hardly it involves 3 steps, I think so. So if you want to find out the harmonic conjugate of any point, suppose P, first you need to identify that P divides the given line segment in what ratio. So that can be solved by assuming the ratio is some k is to 1. So after assuming some k is to 1, by equating either x coordinates or y coordinates, finally we can find the value of k. Okay, and we assumed the ratio is k is to 1, no? P divides in the ratio k is to 1. That's what we can simplify in this manner. Finally we got the ratio is 3 is to 2. So this is the step number 1, that we want to know the given point divides the given line segment in what ratio. So we got that ratio as 3 is to 2. I mean, if P divides in the ratio 3 is to 2, then as per the definition of harmonic conjugate, Q divides AB bar in the ratio minus 3 is to 2. Isn't it? Now I know that Q divides in a particular ratio. So to find out the coordinates of Q, once again I know that A and B, and I know even ratio, hence I can go with section formula. And then finally we can find out the harmonic conjugate of a given point. Next concept is about area of a triangle. So basically, when we want to find out the area of a triangle, mostly we recall the formula that area of a triangle can be formed by using the formula half into base into height. But you know, my dear, it is not possible for every time to find out what is the base of a triangle and what is the height of a triangle. So that is why here we have another formula when we know the 3 vertices of a triangle. So just look at the formula once, everybody. So area of a triangle formed by the points capital A x1 comma y1, capital B x2 comma y2, and capital C x3 comma y3 is half modulus of sigma x1 into y2 minus y3. Since it is an area of a triangle, it can be expressed with square units. Okay, so let us see the expanded form for this. Therefore, area of a triangle, area of triangle ABC is equals to, sigma is nothing but summation. We already discussed in polynomials. Okay, let us see the full form for this, the expansion of this sigma notation. Just very simple, just you please remember like x into y minus y plus x into y minus y plus x into y minus y. Just you can simply remember this technique. And we have 1 2 3, no? 1 2 3 1 2 3, just you write it. So first one is 1 2 3. Okay, so 1 completed, no? Now start with x2. When you begin with 2, Therefore, your order is 2, 3, 1. So 2, 3, 1. After x2, we need to start with x3. So when your order is 3, therefore look at that order is 3, 1, 2. So 3, 1, 2. So this is the way which easily you can remember. And look at the finally the formula for area of a triangle ABC is half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Because of area, better express with square units. Okay, let us solve one problem. Coming to the problem, find the area of a triangle. Find the area of a triangle formed by the points capital A 5, 2, capital B minus 9, minus 3 and capital C minus 3, minus 5. So first of all, given points, first point you can assume it as some x1, y1 and second point is always x2, y2 followed by third one is x3, y3. Then write the formula of area of a triangle ABC, that is half modulus of, replace these values now, x1 which is 5 into y2 minus 3 minus y3 which is already minus 5 now, so minus of minus 5 will be plus 5 plus x2, actually x2 is negative minus 9, so minus 9 into y3 value minus 5 minus y1 value which is minus 2 plus x3 is nothing but minus 3, so plus into minus anyhow minus, no, minus 3 into y1 which is 2 minus of minus 3 which is plus 3. So just we need to simplify. So 5 into this is 2 minus 9 into minus 7 minus 3 into 5. So half modulus of 10 minus into minus plus 9 7s are 63 and minus 15. So half modulus of, if you add first 2, 73 minus 15. So half modulus of half modulus of 58 which is equals to 29. Hence therefore area of triangle ABC is equals to 29 square units. Okay. So you please try one more problem, that is find the area of a triangle with the points minus 1, 6, minus 3, minus 9 and 1, minus 3. So this is your question. Find the area of a triangle formed by the points minus 1, 6, minus 3, minus 9 and 1, minus 3 and text me the answer. Okay. Thank you. Thank you for watching this video.